Uniform infinite plate charge. To start, let's review the result from the finite circular plate. We found that the total charge was the surface charge density times the area of the plate. And so that in this case would be pi r squared. But if it wasn't a circle and we were somehow able to calculate the surface area S, we could calculate the total charge. The total field was the surface charge density over 2 times an expression in the z direction, and this expression was accounting for the finite size of the circular plate. What is the total charge when the radius of this plate goes out to infinity? Well, from the previous example, the total charge was rho s times the area. Well, if the radius goes out to infinity, so does that surface area. So the total charge is the surface charge density times infinity. So as long as that surface charge density is not 0, we always have an infinite charge. We might get a negative infinite charge if the surface charge density was negative, but we'll always have an infinite charge, total charge. Total field. This is the expression we got for the finite plate. So all we have to do is set r to infinity in this expression. So what do we get? Well, in the denominator here, we would still have infinity. We'd have some number divided by infinity. That would go to 0. 1 minus 0, that's just 1 inside here. So everything in parentheses, we could just drop out of the equation. And we're just left with rho sub s over 2 in the z direction. So it's interesting then for an infinite sheet that the total electric flux does not decay with distance.